Today we start discussion of potential energy. Potential energy. So, what is potential energy of a charge system? So, if you consider a source charge plus Q and bring a unit test charge, a positive test charge from infinite to point, suppose here, from point P, infinite to point P, bring a test charge, and the value of test charge is very small, that is plus Q, very small, okay. And these test charge experience some force due to source charge, and if test charge with a positive and source charge with a positive, so the direction of force experienced by test charge is force, and that force is a repulsive force because both charges are like charge, okay. Now if that separation between these two be that R, question is R, okay, so the work done, okay, and we know that work done and energy are related, okay. So work done from being a test charge from infinite to at point P, okay, from infinite to point P means R, from infinite to point R. So apply the external force, and that external force in that direction, that's the external force or applied force in that direction, okay. So that's the F external dot is a vector, so the dr, okay, if the gap dot is R, so dr, okay. And external force, you see that external force and that repulsive force, or call that electrostatic force, these two force, and that force is electrostatic force, these two forces are opposite direction. So infinite to R, and external force is opposite direction means minus electrostatic force dot dr, okay. And if I change the limit R to infinite, then the minus omit here, so that's when we finally get F electrostatic force dot dr, okay. So here we put a limit here, so electrostatic force is uh, plus Q source charge test charge small q over 4 pi epsilon naught R square, uh, R to infinite, and that's dr, okay. So both are in same direction, that's why be that cos 0 be the 1, okay. So capital Q small q over 4 pi epsilon naught R to infinite, so dr by r square, and you know that integration of dr by r square from 0 to infinite, we put here the capital Q times small q or 4 pi epsilon naught. So dr by r square we get minus 1 over r, here the integration limit r to infinite, okay, and that is capital Q small q over 4 pi epsilon naught, okay. So put the limit here and we get 1 by infinite 0, okay, minus and minus minus plus 1 over r, 4 pi epsilon naught times r, that's the work done, and unit is joules. And there is a relation between work done and potential energy, there is a relation, okay. So what is the relation and what kinetic energy theorem? We know that from delta U, change in potential energy, okay, from bring a test charge from infinite to a finite point. Okay, final potential energy minus initial potential energy. So final means potential energy at point P and potential energy at infinite. So potential energy at infinite be the zero. Infinite be that zero. Okay, so that is equal to delta U, that is equal to UP. So change in potential energy, that is equal to work done. So finally we get capital Q small q over 4 pi epsilon naught R joules. That's the final expression. So U equal to capital Q small q 4 pi epsilon naught R. That's the potential energy. Okay, clear the concept. That's the basic 5 minutes of potential energy of two charge system. Okay, if you want to more about that, I put the full lecture in I button. Please click that link and watch that full lecture. Okay, so today in the class here. Thank you.